frame to that layout. So I click on the map frame button here, and you see the map frame that I was showing there got added. Perhaps I want to resize it. Perhaps I want to activate it so that then I can zoom in and out. So maybe I'll arrange it the way I want it to be. But now the question is, what if I want to put a different layout in the bottom half of this page that shows a different part of the same data? So the way that we figured out how to do it is to go back. Well, I'm going to get back to the layout mode from this link, which effectively unactivates that map frame. I'm going to make a new map. So now you see across the top here, I've got map 1 and also my original map and the layout. Map 1, all it has is the base map in it. I can go to map 1 and, for example, just copy one of the layers, and then if I switch to map 1 and I click on the data frame at the top and do paste, that layer will come in with all of its symbology the way it was. Maybe I want to add something else. Maybe it's I want the outlet file to be there. So now I've got a separate map with a different set of data. Now I can switch to my layout, and under the map frame option I can get to choose the maps I want. So I'm going to go to map 1. I'm not sure what the difference is between picking default and map 1, but it works if I pick map 1. I think the default will go to some sort of a default scale, but if I click there, I now get map 1 displayed here. Maybe I can activate it too by right-clicking and going activate, scroll out to get the scale I want. Perhaps I want to insert some decorations. Where do I add scale bars and the like? So do I have to be unactivated? So then I maybe want to add a scale bar. Maybe it's a simple scale bar, and I'm hoping this is somehow associated with. I don't know how we associate it with a specific map. Let's assume that we've got this one associated with that map frame. If I was to then activate this and zoom in, then go back out, the scale bar did not change. But if I'm activating this one and zoom, notice the scale bar changes. So now we know that the scale bar is associated with this map, which is a comforting thing to know because I've put it on that map. So that's the way you can work with multiple maps on the same layout that way. And then there's no problem having the same data in the different maps. If I was to say switch to this map, well, let me switch to this map view, grab this digital elevation model, which is the southern one, the one for the Blacksmith Fork River, and copy that and put it on this layout, but I'll just do that by paste. So now if I scroll out a little bit, it's down there, so it's got both of those. If I go down here, the second layout gets that as well. So whatever's on the map is on the map frame in the layout, is the general pattern. So any other questions related to working with maps and layouts and things like that?
Why would you not just add a second map frame from the same map to your layout rather than creating a second map?
Okay, so the question is, can you effectively do what you were just describing there, David, by adding in the first layout the map itself, just add it twice?
It doesn't work that way. It would be nice if it worked that way, but when you change layers and you change scales on the one, it tends to, it does it on both of them. So let me delete this, this map frame. So I'll delete that, and then let's go and create a second map frame that is the first map, and perhaps I can activate it, and it's in a different, it's showing a different location, but I can't have the data be different, because if, for example, I uncheck that layer, notice that it goes away on both of them. So you can't have a set of separate layers selected for showing on the different map frame.
So when you create a new map frame, all you're doing is displaying the data again. You're not changing anything. It's just you're just looking at the same data in a different perspective. And in the second map frame, you can even have a different projection if you want. You can just change the projection of the map frame and have albers or who knows what, even if the original data were in a different projection. So the map frame is a holder, a folder, you could say, that is used to display a particular set of feature classes and grids. And the same data, or a portion of those data, can be presented in another map frame, or indeed however many you want, and then the layout can be comprised of the composite of the map frames that you've got for displaying the data at different resolutions.
Okay, so there was a question that came in email. Do you want to address that quickly?
It's a bit more than I can figure out how to express in my mind.
So is the student there who asked it
Yes,
want to express the challenge?
So Cesar, why don't you explain what your question was?
So when we're calculating the average depth to use to calculate the volume, we first got this TIFF file that's for the depths.
Mm-hmm.
But to calculate that TIFF file in the raster calculator, we put whatever level we're looking at, so 1 or 6 or 14, minus the hand raster over the boolean that we have, the less than 1 or less than 6.
Uh-huh.
So the question is, why is it 1 minus hand over the boolean instead of just hand over the boolean? Because 1 minus will, I think, will effectively give you the depth from top, from 1 up to the hand, but we're interested in the depth from below, from 0 up to that level, because then we're multiplying it by the inundation area.
Okay, so let me.
Okay.
Sorry, what?
Okay,
Why don't you take it? Take the question.
So firstly, it should, if you're dealing with a depth of 6, it should not be 1 minus, it should be 6 minus, because it's doing the depth from the water level that's represented by, say, 6 down to the elevation. So that might be clearest if we were to look at one of the slides from this presentation.
But I guess the question is, why is it from top, not from bottom?
Yeah, we'll get there. Yeah, this one. Yeah, this is a good slide. Yeah.
So if you think of this horizontal blue line at the top here might be the level, say 6, and you're doing 6 minus, you're trying to calculate this distance, which is, let's say, the distance from there down to there. So it's the 6 minus the hand value. The hand value is the height of this point on the surface above the stream. So you're doing the calculation from the water surface to the ground. And then you calculating that only for the places where the water surface is above the ground. That's why you're dividing by the Boolean result. And then you're taking the average of that.
Is that clear, Cesar, or not?
Yes, but the question is, why are we interested in the height from top instead of the height from
Okay,
bottom?
so the question is, why is it from the height from the top and not from the bottom? And that's because when we're calculating the properties of the channel, we want to calculate them on the volume of the water itself and not on the characteristics of the ground. So if you imagine where Dr. Tarleton...
This is where the water is.
Yeah, that's where the water is. So in other words, we're seeking the volume of the water and not the volume of the ground. The hand is measuring the distance from the stream bed up to the point where the channel just stops and the water starts. Can you draw a line from where you've got the line you just drew, David, down to the bottom? Yeah, from there.
So if I was to draw a line from there...
Yeah, from there down to the bottom.
there.
Yes, in other words, for that location, the hand value is the elevation from the stream bed up to the channel. And then the depth, the 6 or the 1 or whatever, minus the hand value is the thickness of the water that then, or the depth of the water that then exists at that point. And what we're trying to do when we're calculating the characteristics of the channel is to take the surface area and the volume and so on of the water and not of the ground. Yeah, that's why we're doing it that way. It's it's a bit hard to imagine in your mind because it's sort of like we're going backwards. You know, we've got this thing from the bottom up, which kind of makes sense, but then we're going, oh, now we're going from the top down. But really, the purpose of going from the top down is to get the water, is to capture the water volume in there. Okay, any other questions about exercise 5? You're all excited about exercise 5? Yeah. Okay, that's great. I was excited about exercise 5.
I don't think any of you are as excited as Dr. Maidment was about this. He was over the moon.
Yes. Well, it's good to do things for yourself instead of having to depend on
Yes.
somebody else doing it for you.
Okay, so today, programming. So I'm going to give you a scratching of the surface into programming, just enough of a glimpse to hopefully empower you to do a little bit if you want to or need to, and give you a pointers for how you might be able to dig deeper. So we might ask, why do we need to worry about programming? And we've seen this slide before. The first thing is automation of repetitive tasks. You might want to do the same thing again. You've seen that it's fairly tedious to calculate the rating curve using the hand method by hand for just one channel reach. Well, now you've got 27 million over the whole continental US. What are you going to do? Get 27 million people? That's what they would have done in the days before computers. And they actually had a profession called computer that people did these sort of calculations by hand. But now you would just program a computer and it will be done very quickly. You might also want to program functionality that's not available. Perhaps you want to implement something like D-infinity. So that's what I was thinking about when we first came up with it. And then you eventually publish the paper, and then a major software company, if they think it's a good idea, picks it up. But that's several years later. So if you want to do something new, you might have to program it yourself. So those are the two reasons to think about why you program. There's 3 views of GIS that we've also talked about before. One is the geodatabase view, thinking about the way we organize data can really help or hinder, if it's badly organized, the way we can work with things. The visualization view, how to symbolize information so that it's clear to the reader, and the various map frames, the views, the scales, the labeling to support an analysis. And then there's the geoprocessing perspective on it, which is information tools that derive new geographic data sets. And we've done quite a lot of that in this class. We've started from a digital elevation model and gone through the process of enriching it by calculating things like the slope, the flow directions, the watersheds. When we started with a square digital elevation model, there was no structure that was readily apparent that you could think, oh, these are the watersheds associated with it. After you've done all your work, you've got a whole bunch of data layers, and they tell you information about the way water would move over the surface. So that's deriving new data sets. So there's quite a lot of help information available in the help, so I'm going to just point you to some guidance on that. So this is the page that's in the ArcGIS Pro help on what is geoprocessing, and it describes a little bit about it, and then it says you can use it to create custom tools through Model Builder or Python scripting, and we'll be focusing on the Python part today. We focused on Model Builder earlier. There's a section where you can actually look at Python and you can read about Python and geoprocessing. So let me go into that page. There you see that what is geoprocessing section. If you decided you wanted to learn about Python, now Python is a very popular, fairly easy to learn programming language that ArcGIS has adopted as its scripting language. So you can get this page sort of starts out with talking about the ArcGIS Pro Python reference and getting started, and it talks about installing Python, ArcPy libraries. You can also just click on the Get Started button in Python and ArcGIS Pro, and then it explains a little bit about it. And then it's got information about learning Python, which will take you to the Python website, the Python tutorial, Python for non-programmers, language reference. Then you'll go down to the Python tutorial for programmers, and getting into some more advanced topics. So there's a lot of information out there, and I just wanted to point you to some of those basic things. And specifically, if you want to get started with Python, I'll show you some things that sort of are more or less the learn by doing approach, where once you know enough about the sort of syntax and the concepts, you can just try things out, look things up. I heard it once said about programming, understand the structure of what you're trying to do and Google for the syntax. Because especially if you work in different programming languages, you may not always be familiar with these things. So this again is the Python website, and then the various Python tutorials, and you see these are going away from ArcGIS Pro into the sort of mainstream Python documentation and literature. So there's a number of options for programming with ArcGIS. We saw Model Builder before. The Python scripting environment is what we'll focus on today. There's also other things that we're not going to deal with.
Could we go back to the previous one? Okay, let's suppose I'm a neophyte. I know nothing, right? Where's step one? Like, hello world or something like that.
So probably Python for non-programmers.
Okay.
So if you've never programmed before, tutorials on this page are recommended for you. So this will tell you, give you a number of books you can choose from, and I guess it looks like quite an intimidating list.
It's only for children, right? K to 12, that looks like build a pipette. That looks like about my level there. So learn Python step by step. So oftentimes the hardest part, this is actually a very good question, because the hardest part with programming is actually knowing where to start and getting the environment that you can work in, where you can start doing the first program that sort of says hello world, or my C equals A plus B, and evaluate that. So I'll give you a little bit of that getting started today, but there's probably more to be learned. Anybody who's a Python programmer who would recommend anything different to what I've said?
use Code Academy.
Go ahead.
It's Code Academy. Yes. Emma.
I'd say just find a task that you actually need to do and do that. Like, it's a way better, or at least for me, it was easier to learn when I actually have a task. I'm like, okay, well, I need to do it anyways. I'll try to automate it so next time I have to do it, I don't have to repeat myself.
Okay, so Emily says, have a task that you need to do and then figure out how to automate it, because then you know what it is that you're trying to get done. Okay, that's good. One thing that I found... Go on, David.
So I think that's very good. I mean, when so the task we're going to do today is basically figure out how to do exercise 4 in Python.
So let me just say that I found it also in these kinds of things useful not to try to start from the very beginning, but to start with something that already is there. And that way you can kind of figure, oh, they're doing this and this is done like that, and if I wanted to do some small variation on that, well, I could change this from that. And that way I'm only changing like 5% of the thing rather than having to try to create the whole thing from square one. So that's another way to kind of get an angle into this kind of stuff if you're, just a total neophyte, which is what I am actually.
So, so there's the model builder, there's Python scripting. There's also other things. I'm really just mentioning these because they exist. We're not going to touch them. There's an ArcObjects library to call from systems programming languages such as C++, C#, .NET. For the real old-timers, there's Arc macro language, which was the language used prior to ArcGIS adopting Python. And they had some other incarnations of languages in between, like Avenue, that I don't think exist anymore. There's also another point here that I want to make is that I think actually helps with programming is using open standard data formats that anyone can use in programs. So for example, shapefiles are an open format for geographic feature data. The shapefile definition model was published by Esri, so other people can pick it up, and you get lots of programs that can read and write against that, and that actually makes for sort of community use and community sharing. I've worked with GeoTIFF files for gridded data because that's also open. I can write a program that reads and writes GeoTIFF files, and I don't have to worry about it having to depend on a library that's locked into ArcGIS, and I may not always be able to use it. NetCDF is another file format like that. So by programming against standard formats, you end up being able to collaborate a little bit. So ArcGIS actually has a Python environment built into it. So I'll talk about sort of a few options here. The simplest way to start with Python is, well, at least the simplest way if you're working with ArcGIS is to just use the Python window that's built into ArcGIS, and it's got a little box, enter Python code there. You can start typing Python code, and it'll start doing the calculations. With all installations of Python, there's a simple editor that's known as idle. I'm not exactly sure what idle stands for. It might be being lazy or interactive something learning environment. Perhaps, I don't know. So we will use idle today, and it lets you edit Python files. Python files typically end with .py. You can also run them directly with ArcGIS Pro. If you're going to get into anything more than casual programming, so I'm not going to say serious programming, but even for sort of modest programming, I would recommend getting a development system such as PyCharm. There's other ones available, but PyCharm is the one that a lot of the developers around here use, because that actually allows you to set up the program, and then you can step by step go through it, and you can see the value of the individual variables as you're going along, and that's a really useful way to learn. And it'll also help you if you don't get the syntax right, it'll underline it in red. If you don't, you start typing and it'll fill in the words that it's anticipating you're going to write. So we'll do that. We won't get into working with PyCharm today, but if you want to, you can. So, each
David?
geoprocessing tool, go ahead.
IDLE stands for Integrated Development and Learning Environment.
Okay. Thank you. Doesn't stand for what I'm on Sundays, does it? Each geoprocessing tool, and we've worked with a lot of geoprocessing tools, has its own Python command. So if we do, say, geoprocessing with the fill function and we run it, we can then copy the Python command, and we will see what command actually ran behind the scenes to do the command we did. And that's a useful way to learn things involved. So you can actually step by step go through the sequence that you're interested in, and then capture each line and build up your program that way. So I'm going to do a bit of a demo today. We're going to look at Python code from the geoprocessing history, the use of the Python window. We're going to get Python code from online help. We're going to sequence that code into a script, and we're going to edit and run it with IDLE. So here I've got ArcGIS Pro open. Let me get, so I'm going to get back to where I don't want my layout anymore, so I'm going to delete my layout. I'm going to delete the other map. So in the data that I provided, so for the class today, there's this slide set. There's also mywatershed.zip, which is a zip file that has a folder, My Watershed, and a bunch of files in there, including this My Watershed project. I put that on my desktop, and I opened this project, and that's what I've got open here. So this is a digital elevation model that covers the Blacksmith Fork watershed. Some of those, well, the students in this part of the world will be familiar with it. There's a lovely drive and bike ride up this canyon. So we might want to, we might set out and want to do watershed delineation for this. So what's the first step in watershed delineation?
Fill the pits.
Fill the pits. So let's find the geoprocessing toolbox and look for fill, and it has to create the cache for me again. So I'm going to go into fill, and it says the tool is not licensed.
No, you have to turn it
This
on.
is interesting.
Turn on the extension.
So the people have been fiddling with this computer, which is confusing me. Configure my licensing options. Is this where I have to do it? Can it let me do all of them?
Can you just go down to Spatial Analyst? That's the one that you need, isn't
Yeah.
it? There you go.
Let me just get a few. I don't know why it doesn't have all of them there. Anyway. Well, I think if I was actually in that, I'd be okay. Try that. No, all right. I'll go with that. Was it this one? Okay. Spatial analysts. Okay. All right. It's going to want to shut me down anyway. So then I'm going to go with the named user license because I know that works. Well, I hope it works. So save changes to my watershed. Let me not save any changes. So I think that the staff have been trying to be too helpful. So they have installed these computers so that they use the concurrent licenses, so you don't actually have to log in as a named user. But if you don't have all the software involved, then actually slows you down. So let's get this. So get my analysis tools, fill, and the input surface is the DEM. The output surface, I'm just going to call it, I'm going to put the results in the geodatabase. I'm going to call it fill, and now I'm going to run this tool. So this is the standard process that we've seen quite a lot. Now it's completed successfully. I can actually go to the catalog here, and I can find, there's a little tab called History, and I can see a listing of all of the commands I've run. So far it's just one. I can right-click on that, and I can copy the Python command. So that's one handy thing to do. Now the command is actually off in my hidden clipboard buffer, and I'm going to open Notepad. You might actually use a fancier text editor if you're doing a lot of work, but I'm just going to paste from Notepad. Let's wrap the words, and can I get to have a bigger font so that you guys might have a chance of reading it. So this was the actual Python command that was executed there. It said out surface raster was the result that was being assigned. It ran the ArcGIS station analyst, that's what .sa stands for, fill function on my DEM. There were no other, or whatever the second parameter was, and I don't actually know what that parameter was. We could look it up. It ran fill on that, and then it took the surface raster and saved it in this location. See users classroom desktop, my watershed geodatabase fill. So if I was to say run that in Python, let me go back. So on the top here under the analysis tab, you can see there's a little Python window. So if I show that, I get this Python window, and at the bottom it says enter Python code. So maybe what I want to do is I'm just going to fill. I'm going to type this same command, but before I do that, I'm going to be watching project here and the folder locations and what's in my geodatabase. There's just a digital elevation model and the fill there, and now I'm going to copy that. I'm going to paste that in there, and I'm going to type enter, and now it's actually executing. Now it's done, and you see what happened. It moved from the window where it said enter code up to above, so that's keeping record of the things I did. It created a new raster to my map, out surface raster, and also added it to my geodatabase just with the name fill_DEM. That was a default handy name, or that's the default name it uses. And then I may want to save that, and maybe I want to save it with a different name, so I'm going to change that to fill2, and I'll copy the rest of this command, and paste that there and enter that. So now you see that, well, if I refresh this geodatabase, the thing that was named fill DM got changed to fill 2, so it really saved this out surface raster object with that file name. It didn't change it over in the table of contents. So there's a little bit of different behavior when you're working with things from the Python command line as when you're just doing them from the tool, because of the naming of these things in the table of contents. So if you wanted to have it have a different name in the table of contents, you can go into properties, and I could change it there to fill2. That's the name that's displayed. I can also go into the source here, and you'll see this is where there's a data set that in the geodatabase that gives its location. So if I click on OK on there, it'll change it there. So this was my very first my first running of Python code. Some of you may know a little bit of Python, but it's a very, even if you don't know a little bit of Python, you might be able to guess at some things. I can say something like A equals 2, pi equals 3.14159, and then I do, I do a calculation of A times pi and enter that, and it'll give me the answer 6.28. So it's really just it's doing simple calculations and assigning of variables. It's a pretty sort of intuitive, interpreted language. So those quantities, those concepts were in there. The next thing I might want to be doing is flow direction. So let me do a search in geoprocessing for flow direction. So let me open another tool, flow direction. And rather than doing the process of running it and copying the function, let me go into its help information, and you see the standard information that you've been seeing about all of these functions, where we've been having you read some of this to learn how to work with it. But somewhere down near the bottom, it's got things like, well, it's got a syntax. So now this is a Python syntax for that flow direction. And at the bottom, it's got a code sample. We haven't, we've sort of skipped over the code sample before, but this is Python code that we could execute to actually do the flow direction calculation. So I'm just going to copy all of this, and I'm going to go back to where I've got the text editor here, and work with it. So the 5 lines that I copied are first import ArcPy. That just says I'm going to use the ArcPy library. Then it says from the ArcPy library, import the environment. That's the object that keeps track of the variables or the sort of computation environment I'm working in, where the scratch folders are, where the output files are. Then it says from arcpy.sa, that's the spatial analyst part of ArcPy, import star. Star is a wildcard, and that means all of the functions. Then I can do environment workspace equals C SAPy data. This is not going to work for me because I'm not actually working in this folder on my computer. I'm working in this folder, C users, classrooms, desktop, my watershed, GDB. So I'm going to copy that, overwrite that down there, and do a bit of tidy up here that I know I have to because of the syntax. There's this little R in front here that is sometimes a little bit awkward, and people ask what it is. It means that you interpret whatever's in between the quotes as raw text. Otherwise, it does things with the backslash and interpreting that as as special characters. So this line here says that the workspace that I'm going to work in is my geodatabase. Then it's going to calculate flow direction, but I don't have any layer called elevation. Instead, I've got a layer called fill, because I do my flow directions on my fill. I'm not sure what the normal stands for, so sometimes when you're programming, you don't necessarily have to worry about it. If I did worry about it, I can always go back to the documentation, and I can see that it's actually got parameters. The second parameter is a force flow parameter, and it is normal is if the maximum drop on the inside of an edge is greater than 0, flow direction will be determined as usual, otherwise it will be towards the edge. And force will force all cells to flow outward. So you can choose between those as parameters for how it handles the edges. And then you can optionally put a drop raster in, and you could actually put D8 or MFD or D infinity. That's optional, and the default is D8. So I'm not going to put those, and then I'm going to save the results. And I also need to save the result in my workspace here. So rather than this location, I'm going to put that workspace location, and I'm going to need to give it a name. Probably I'm going to call it FDR for flow direction, and I'm also going to have to put the little R there to tell it to apply a raw interpretation to the text in between those quotes. So those are now 6 functions or 6 lines of Python that I can take, and I can just copy those, and I can go to ArcGIS Pro, and I can paste them down here in the Python window, and then I have to type enter, and I think I have to type enter twice to be on a empty line, and then it'll execute all of those 6 lines all at once, and it happened faster than I could even talk. But you see we got output flow direction reported. If I look back in my catalog, you can see now there's a flow direction raster in my geodatabase. Strictly, I probably didn't need to do the import ArcPy and the from ArcPy import environment, because I'm working in the Python command line that's sort of built into ArcGIS, and it's sort of understood it's got those libraries already. But if I was programming outside somewhere, then I would need to use those. So so I can do that. So now maybe I want to do something a little bit more ambitious. Maybe I want to calculate the D infinity slopes. Go ahead.
Can you use Python scripting when you
Um, I don't think you can use it when you don't have the license. So, so that's one of the limitations of, you won't be able to use the ArcPy library if you don't have the license. So you'll need to have ArcPy on your computer and licensed for this to work. So that is one limitation, and there are a lot of open source Python tools that you can use, and I typically program with those so that I don't have to always be bound to the licensing.
Why did it name on the table of contents? Why did it name it outflow direction FDR?
Because this actually appeared on the table of contents from this line, where immediately after I'd done the flow direction calculation, it put it on the table of contents, and then this function here changes the name, but it changes the name of the data sets on disk. It doesn't change the name of the label in the table of contents. I actually fiddled around last night to see if I could figure out a way to programmatically change that, and I was unable to find a way. So if any of you guys are, and you want to get some bonus points or get make me happy, you can email me the solution. But you can go into, so this, if you look at the layer properties, the name of the layer is outflow direction, and that inherited from the left-hand side over there. The source here is that FDR. So let's do a bit of experimentation to reinforce that a little bit. So let me take this same line and redo it, but I'm going to call it 2. So, and if I execute that, and I execute it just by pushing enter, you see now there was a legend there that said, or it added outflow direction 2. You see there's flow direction underscore fill. If I look at the properties of that, you'll see that the source of it says the data set is flow direction underscore fill in that geodatabase. The name there is outflow direction 2. If I then take this next line up above, I guess I have to, change maybe I want to call that, I'm going to name it number 2, and I'm going to operate on the outflow direction 2 object. And if I execute that command, I guess I somehow got rid of the save. So I can actually do an up arrow to get back to what it was, and dot save, and I don't know how that got lost. So now it changed inside of the geodatabase to fill 2 or flow direction 2, and if I look at the properties here, I will see that the source name is now that. So yeah, it just doesn't change that. I would like it if it was easy to change that, and there probably is an easy way to do it. I just don't know how. So you quickly get into things that you don't know how, and you've got to decide which of them are worth actually your trouble to figure out or not. And if it's functional for getting the job done, you have to spend the time to figure it out. Otherwise, you just keep going. So now, let's say I wanted to do this with D infinity. I could look at my help information, which was, where was my help information? Thought maybe it opened it. Okay. So my help information, if I look at the help file, you see it's input surface raster, the forcing of the flow, the output drop raster, and flow direction type. So the fourth argument would have to be the D infinity. So I'm going to guess that if I want to have say dnf flow direction, I'm going to have flow direction on fill. The third argument I'm not going to worry about. The fourth argument I'm going to put DINF. So this is a trick you can use for just skipping over arguments. If you don't want to put anything in, you just put an empty string. And let me just take this line and see if I can calculate that in ArcGIS Pro. Now you see there's a D infinity flow direction. It ranges from 0 to 359, and you've got so you've got D infinity, and it was named floater fill. We could change that name if we wanted. So
that's a cool map.
Doing more or less. Yeah, D infinity makes really nice maps. It's got this sort of silvery, hill shady type of perspective to it. And what looks like ridges here are actually valleys. And this flat part there is will be a lake, I think. So you can actually right-click on this and say, save my transcript, and that'll save all of the functions I've got, and it's going to save it in a Python file. So I'm going to call it my code .py, and now we're going to actually start some programming. So let me go back to my folder. There's the file that I just saved, and I'm going to edit it. So here's the idle editor, and there's, I guess, two choices, idle and idle with Arc Pro. I think there's obviously two installations of Python in this program on this computer. One of them is used by somebody else for something else, and I'm going to pick the Arc Pro one because that's the one we're working with. So it opens this, and you see it's actually it's now got sort of color schemes that help us a little bit interpret these things, but it kept track of all of the commands I put and put it in a single file. So now I can sort of edit these, and maybe I want to have a program that starts doing useful work. So I'm going to just edit this. Anything that begins with a red or anything that begins with a hash is a comment. Let me see if I can change the fonts so that you guys can see it. Do options, configure idle, maybe, okay, there's an option to change the font size from 10, say 16, okay, so let's program this to, I'm going to call this my first Python program today, since I've done a little bit of this before. So then the first things we want to do is some of this import and environment work. So let me take those lines and put them at the top. Then let me say I want to do the fill. So let me say I'm going to create a variable, and I'm going to say the DEM I'm working with is going to be equal to DEM, and then I'm going to run the fill on with that variable. So this is some of the so I can sort of rearrange the code a little bit like that. And maybe I want to save this as probably fill 3 because I've already got a 1 and a 2. Well, I'm just going to go with fill, and I'm going to go back here and delete some of these layers that so that they don't interfere with me when it tries to overwrite. So I'll delete these lines where I was messing around. Then I'm going to do flow direction on the fill result, and I'm going to save that as FDR. And then I'm going to do I'm not going to do it twice. And I'm going to do deinf, flow direction, and maybe I want to save that, so a line similar to the one above. So and I'm going to save this as dinf. So I'm starting to build up a little bit of a program. I can save this code, and now I can run it, and it should, if I haven't done anything wrong, execute all of those as a program. So I'm going to just try run this module, and so now it's actually running. It starts up a Python shell. It's running outside of ArcGIS, but because ArcGIS is open, it's taking care of the licensing. Eventually it'll get to where it finishes. Now Python is a very silent language. If everything, well, mostly it's silent. If everything works, it just returns back a prompt and all is good. If there had been any errors, it would have splurged a whole bunch of errors all over my screen. So the fact that I just got back these three greater than signs means it's finished, and I can go back to look at, well, I can go back and refresh my geodatabase, and you saw I got the flow direction, the fill, and the DEM as results. Those were not automatically added to the map. So that's one difference from when you're working in a program outside, when you calculate something, it doesn't actually know about the map. So it wasn't associated with a specific map, so it didn't add the results to the map. So if I needed to add them to the map, I'll have to drag them on. Maybe I want to extend this program to include flow accumulation. So let me go and well, I'll just show you one other trick. I'm going to do the flow accumulation. I'm going to run flow accumulation by hand, and I'm going to do it on my flow directions, and I'm going to call my results flow accumulation. Don't know what it's doing for it's taking so long now. Okay. And I'm now going to just run this. So previously, when I wanted to get the Python command for something I'd run, I actually went into the history and found it. There is actually a quick way. Once it's finished, you can actually go and on the green report where it's finished, you can just copy the Python command right there, which is a sort of a handy trick. And then I could say take that and I could paste that into there, and let me. So it's now made a very long line, but it says the output accumulation raster was running the flow accumulation, and it was using as input, let me try and make this a bit wider, it was using as input this long string. There was none of these parameters, so keep going off to the right. And then there was this semicolon splits line, so I'm going to actually just backspace over that and do the save function as separately. Now if I now it should be ready to go with flow accumulation. Now, because I've actually set the environment workspace to be my geodatabase, I don't actually need the full geodatabase here, so I can just shorten it. And if I've shortened it that much, I don't need the R anymore. Similarly, over here, it wouldn't have done any harm to leave those, but it's just clutter lying around. So now I should be able to run this. So do you think it's going to work if I try run it?
Yes, I have confidence.
You have confidence. Okay. So let me try run it. So what happened? So I got an error. Runtime error, output raster, data sets. Fill already exists and cannot be overwritten since the override existing option is disabled. So I forgot to clear out my existing results and I didn't have overwrite. I can actually do something like, and I don't know how I found this out. I can do environment.overwrite. Well, I know how I found it out this year was look in my script from last year, but I don't know how I learned this last year. And I can say overwrite the output to be true. Now if I run this function, now I don't have to worry about deleting my files prior to running. It'll just clobber them, it'll overwrite them. So it wants you to deliberately do that, and you shouldn't deliberately do that if you aren't aware that you're doing that, because else you're in danger of overwriting data that's precious to you. So with a bit of luck, that's going to now get to the end, and we should have we should have flow accumulation as one of our results. So again, it's not telling us very much about what's going on. So we'll learn how to remedy that in a little bit. So the only way I know that it's finished is when those three things come back, and I can go back into my catalog, refresh the catalog, and I can now see all of the results, which include flow accumulation, which I could then add to the map. So that's probably. I wanted to go back to the slides to. So that's enough of the sort of just programming and sort of figuring it out as we go along. But I want you to look at the process that I was following was really one of where I sort of had the steps in mind. I knew what I was trying to do from having done exercise 4. So, and then I just sort of learned each step. I looked in the help documentation, I looked at the examples, and I built it up. And programming, for me at least, is often an iterative process like that. Sometimes just 2 or 3 lines at a time to check that they work, and then progressing on. So it can be fairly time consuming, but once you've got the script worked out, it's then fast and useful. Also, errors happen, and I actually knew that error was going to happen, and it's surprised that I haven't had an error that I wasn't anticipating yet, but maybe I've done this lecture too many times. But they'll catch you, and then you're sort of looking at, you have to read carefully and try and discern what's going on and figure it out. That's a normal part of the process, so don't feel bad about yourself when errors happen. So if I go back to the slides here, we've sort of worked through these examples. So here is a script that I actually wrote that's the entire exercise 4, or the steps from exercise 4, built into one script. So you can see here I've got these yellow numbers here, step 1 is setting up the input. So I'm setting up the DEM, I'm setting up the outlet, I'm specifying a threshold. I've actually extended the idea a little bit. I've said this is the output point, and it's going to get snapped onto the streams. Then I set the environment variables. Then I go through the steps: fill, flow direction, flow accumulation, snap the pour point to that location, calculate the watershed to the pour point, calculate a stream raster, calculate stream links, calculate the catchments, calculate stream to features, and which is the vector conversion step. So this was started when I first wrote it in 2016, updated yesterday, and I updated it to add some of the capability that seems to be new in the current version of ArcGIS, which is the ability to have multiple outputs, so we're able to save a step. You guys don't know how, you don't know the more complicated steps that we had to do in previous years as the software is getting better. So we can actually take, that program is provided here, dem to watershed.py, and I can edit it with idle, and I can see exactly the same thing we've done before, and I can run this, and notice it says outdoor is C users DTOP desktop. That was my desktop work on my computer. That's obviously not going to work here, so I'm going to have to edit it to be the C users classroom desktop. So C users. So if I was being completely general in writing this code, I could probably get the location to come in as an argument to the script. Right now I don't have that level of generality to it, but I can, I believe I've got everything set up here, so it's just going to work. Notice I put print statements so that you get a sense of progress. So if I save that, well, if I try to run it without saving it, it'll say it must be saved first. So now it's starting to run it. And now as it chugs through, we might see some progress as it goes along. So it's filled the DEM. So there's an error, and sometimes you get to a state where the geodatabase doesn't want to accept inputs very nicely, and I was able to resolve that previously just by refreshing this, by deleting some of the things that we don't need, and then closing and opening ArcGIS again. So I'm going to close it. So I don't think that was an error. I don't think that error was any mistake that I made. I think it was just it didn't have, or maybe there was something else running that had a lock on that database. You just have to sometimes deal with these things, which I guess that goes to show you that I don't fully understand how it works all the time, and a lot of times with these things, it's really hard to fully understand.
Sometimes if the file has an extension, it doesn't save in the geodatabase. If you're saving it as dot something, it doesn't.
If I was saving it as .tif, sure. Now I don't think I had any extensions here, so hopefully not. Let me try this out now. And let's go back to my Okay, so now it's going through. So it may have been that one of the temporary files it was trying to write already existed and was locked somehow. Is that the error that I got before? Is that? No, it's still going. This is the error that I got before. So it's finished, and I can refresh my database. And there I've got all my results, would include things like the drainage lines. So that's pretty cool. We got to the end, and we have a set of blue lines just from having run the command. I also have the catchments, so I can add those, and maybe I want to symbolize those with just, say, outlines and no color. I don't know why it's taking a... I don't know why it's not showing those.
Can you open the attribute table, see if there's any features there? No features.
Cannot acquire a lock. So something went wrong with catchments. So that'll be another imponderable to deal with. Maybe, yeah, sometimes you actually have to let the Python function close first, or, yeah, I don't know what's, can I open the attribute table here? Has it got an extent? It's got an extent. It's got a spatial reference. Let me remove it, add it again, although I don't have a lot of faith in that. Did everything work? Yeah. Anyway, let's not worry about that. The catchment grid created, then the vector conversions were done, and in my little function down here, so catchment save, catchment grid, so stream to feature, raster to polygon, catchment grid, catchments. So something didn't work with this raster to polygon function. So we could let's put catchments 2 there, and let's get rid of some of these things that are a little bit speculative, and let's take this and try it in my Python code window, and okay, so there, so maybe the simplifying of the features thing, something with related to those arguments wasn't working. So now I've got the catchments delineated for this area. So one of the cool things that you can then do with some of this programming is you can work with different data. So I'm going to go back out here. You'll notice that in my my folder that I've been working in, I had a file, logan.tif and logan.outlet.shapefile, that is actually this area just to the north. So if I add that to my map, there's the Logan digital elevation model. So maybe I want to use that same program to